Have you ever really looked at your electricity bill and just wondered what you're truly paying for? I mean, it seems simple, right? You use the power, you pay the bill. But what if I told you there's a hidden cost buried in that number? A charge for energy that, get this, does absolutely nothing for you. And the answer, believe it or not, might just be sitting in your local coffee shop.
So let me just ask you straight up. Are you paying for electricity you can't even use? It's not a trick question. For a lot of businesses, especially industrial sites, the answer is a very frustrating yes. It means the power company has to push extra energy down the wires, energy you get billed for that doesn't do any useful work for you at all.
And the key to understanding all of this waste is this cappuccino. I know it seems a little weird, but trust me on this. This simple cup of coffee is the perfect way to picture the electricity flowing into your building, and it explains exactly where your money is going.
All right, so let's break down the ingredients of what I'm calling your electric cappuccino. We need to see what your bill really covers. Just like the real thing, it's made of a few different parts, and they are definitely not all created equal. So first up, we have what's called apparent power. The easiest way to think about this is the entire cappuccino cup. The coffee, the foam, the whole shebang. This is the total amount of power the grid has to be ready to supply to you at any given moment. And this is what your bill is ultimately based on, the whole cup.
Now, inside that cup, you've got the good stuff, the active power. This is the rich, dark coffee. This is the real power, the workhorse that actually does everything you want it to do. It's what spins the motor, lights up the bulb, and heats the furnace. This is the energy you actually want and need.
And then, sitting right on top, you've got reactive power. This is the foam. Now, you can't really drink foam to get going in the morning, right? It doesn't do any real work. But, and this is a big but, some of your equipment, especially things with motors and transformers, absolutely need this foam to create magnetic fields just so they can run. So while it's kind of a necessary evil for some gear, it's ultimately unproductive. It's just taking up valuable space in the cup you're paying for. So let's just put it all together. You're being billed for the whole cup, the apparent power. But you only get actual useful work out of the coffee, the active power. And meanwhile, you're also paying for that foam, the reactive power, which does no work at all. Getting this difference is the absolute key to understanding your power bill. And this really gets to the heart of the whole problem. This quote puts it perfectly. You pay for the whole cup, but in practice, you do not consume the cappuccino foam. You're being charged for a full cup of apparent power, but you're only getting the benefit of the coffee inside.
Okay, so why is this foam such a big deal? I mean, a little bit is necessary, we said that. But when you have too much reactive power, it starts creating some really serious problems for the entire electrical system. Let's look at exactly why it's so bad.
All that foam, that reactive power, sloshing around in the grid, increases the total current flowing through the wires. That means you need thicker, more expensive cables just to handle it. It generates useless heat, which is literally just wasted energy. It can make your voltage drop, and to top it all off, utility companies will actually hit you with financial penalties for having too much of it. It's just like ordering a large coffee and getting a cup that's half foam. You're not getting what you paid for, and all that useless foam is clogging up the grid for everybody.
So how do we measure this? Well, engineers use something called a power factor. Think of it like an efficiency score, from 0 to 1. A perfect score of 1.0 would mean your cup is all coffee, no foam. Awesome. But a poor score, something like 0.70, means that 30% of the grid's capacity is being wasted just to carry that useless foam to your doorstep. That's a huge inefficiency.
Okay, so that all sounds pretty bad. But here's the good news. There's actually a really simple and elegant solution to this whole problem. We can basically fix our electric cappuccino to get way more coffee and way less foam. It's all about canceling out the waste. So here's the crucial idea. The problem comes from inductive loads, things like motors. They consume reactive power. They need that foam to build their magnetic fields to spin. The solution? We add capacitive loads, which are basically capacitors. They do the exact opposite. They supply reactive power. You can think of it as them making anti-foam that just cancels the real foam out. And here is the real aha moment. When you put a capacitor right next to a motor, they basically form a little team. The motor is saying, I need foam, and the capacitor says, I've got anti-foam. They end up supplying each other's needs right there, on site. That reactive power just bounces back and forth between them, and the utility company, well, they don't have to send it all the way from the power plant anymore. The grid is now free to deliver just the good stuff, the coffee.
So how is this actually done in the real world?
This isn't magic, it's a pretty straightforward engineering toolkit that gets used every day, in factories, big buildings, you name it.
The whole solution is a coordinated system. You've got a capacitor bank, that's your box of anti-foam. Then there's a smart regulator, which is like the brain of the operation. It's constantly measuring how much foam is in your system. It then uses these special, heavy-duty switches to turn on just the right amount of capacitors to neutralize it in real time. And of course, it's all protected by fuses to keep everything safe.
And, there are a couple of main ways to do this. You can use what's called individual correction, where you put a small capacitor right next to a big motor. That's great, because it cleans up the wiring inside your own building too. Or you can use central correction, where you put one big capacitor bank at your main electrical panel. That's often cheaper and works really well for places with lots of smaller machines all over the place.
So what is the end goal in all of this? Well, it's all about achieving that perfect power factor, which really just means you're finally getting the full cup of coffee that you're paying for.
The target score, the number you're really aiming for, is 0.95 or higher. What that means is your cup is 95% pure coffee and only 5% foam. In fact, most utility companies actually require their big customers to stay above 0.90 just to avoid getting hit with those penalties. Hitting this number is a clear sign of a really healthy, efficient system.
And the payoff for doing this is huge. Your electricity bills go down because, poof, no more penalties. You waste less energy as heat, which is obviously great for your wallet and for the environment. You can often run more equipment on your existing electrical system because you've freed up all that space that was being hogged by the foam. It is a win for you, and it makes the entire grid more stable for everyone else too.
So the next time you look at your power bill, think about that cappuccino. The whole goal here was to make an invisible kind of waste visible. And that leads me to a final question for you. What other invisible inefficiencies in energy or anywhere else in our lives are costing us money without us even realizing it?